Okay, so Linda loves ice cream so much that after returning from Costco with some ice cream, she eats 40% of the ice cream she just bought. The next day, she eats 40% of the remaining ice cream and then continues to eat another 40% each day. So she's eating 40% of the ice cream every day for 4 days. And we want to know what percent of the ice cream will Linda have left after the 4 days. Okay, now since it doesn't tell us how much ice cream, and we want to know a percent at the end, what's wise is to go ahead and make up a number for the ice cream. Let's say that it's 100 something. Maybe it's 100 milliliters, or maybe it's 100 ounces of ice cream. It's good to use 100 because we're dealing in percents, and percents are always a fraction out of 100. All right, now we could just multiply by the 40%, and that would tell us how much she eats every day, but there's a shortcut. Anytime we have a discount or an amount that is taken away, if we multiply by 1 minus the 40% as a decimal, or 1 minus 0.4, that's going to tell us how much is actually left over without having to do it in 2 steps. So in other words, we're going to take 100 times 0.60, and that's going to tell us that there is now 60, after the first day, there's now 60 ounces or 60 milliliters of this ice cream. All right, now second day, let's do exactly the same thing. We have 60 milliliters left, or 60 ounces left. And let's again just multiply it again by 1 minus 0.4, or really by 0.6. And I believe that's going to give me 36. Let's see. Yep. So now there are 36 ounces left. And let's go to day 3. Now I'll just shortcut it now. We know that the 1 minus 0.4 is 0.6. So 36 times 0.6 for the third day. It's going to be 21.6. Pardon my dog in the background. And then finally, let's take that 21.6 for the fourth day and multiply it times 0.6. And we get 12.96. And I'm guessing we want to round this to a whole number. So 13 ounces, or 13% really is what we're looking at. So if we go back, round to the nearest whole percent, so 13%. And of course that is what we need here. All right, now let's go to the other one you had questions about. I believe it was number 8. And number 8 is the same sort of problem. The only difference is, instead of having the same amount, the same percentage amount like we did a minute ago with 40% each day that she was eating ice cream, we have 2 different percentage amounts. But we're going to do the same idea. So the store has clearance items that have been marked down by 40%. They're having a sale advertising an additional 30% off. What percent of the original price do you end up paying? So let's do exactly the same idea. Let's just call whatever we're buying $100, and that way we'll get a percent, because the percent is a portion of 100. All right, so we'll call it 100, and we'll multiply by 1 minus our 40%. So let me go back here. 100, 1 minus the 40% as a decimal, or 100 times 0.6. So now, after the first discount, whatever we were buying is 60 bucks. All right, now, I believe the second percentage was 30%. Yeah, additional 30%. So we'll do 1 minus 30%, or 1 minus 0.3. So that's going to be 60 times 0.7. And that's probably 42. Let me make sure. And it is. All right, and that is actually how much of the original price that we ended up paying. We're paying 42% of the original price. And of course, we can check ourselves when we come back. All right, so anytime that you aren't given the original price, but you have these markdowns, or even markups for that matter. Now markups would be 1 plus 40% if that happened. I don't think any of our problems are markups, but but you'll have 1 minus whatever, and just call your first cost 100, and you'll end up with the percentage at the end that you need.